My name is Pas, and today we will talk about our next section of our recommendation system, the recommender class. In our past section, we talk about the data loader and the model. The goal of our recommender class is to generate personalized item recommendations for a given user by predicting and ranking item scores using a trained model. It evaluates all items for a user, sorts them by relevance, and returns the top recommendations. First, we have to import our library PyTorch. We need this library for tensor operations, handling devices, and the module computation. Next step is to define our recommender class. And we need to define our class constructor. That constructor initializes the class with model, that is the train recommendation model, and num items, that is the total number of items available for recommendation. We can see one more argument in our constructor called self. Self is a reference to the instance of the class being created. It allows the instance to access its own attributes and methods. We need to create new variables, model and self-num, num items. These variables will store the provided model and the number of items in the system as an instance variables so they can be used in other methods. Next, we have to set up the device for computations. If GPU is available, we will use it. Otherwise, we will use the CPU. Now, what is a CPU and GPU? CPU comes from Central Processing Unit, that is the main processor designed for the general purpose tasks. It is optimized for sequential operations, making it versatile but slower for large-scale parallel tasks. GPU comes from Graphic Processing Unit, is specializing for handling multiple operations at the same time, suitable for parallel tasks like graphic rendering and machine learning computations. In machine learning, GPUs accelerate training by handling many calculations in parallel, making them much faster than CPUs for large-scale data processing. Next line. We are moving to the chosen device, GPU or CPU, enabling faster processing if a GPU is available. And after that we have to define a new function called recommend items. In that function we are setting self, that we discussed already, user ID and recommendations that we are setting by default 5. We are converting user ID into a tensor and moves it to the specified device so it can be used in model computation. We are creating a tensor containing all item IDs and moves it to the specified device. This will be used to evaluate all possible items for the user. We are setting the model for evaluation mode, which disables certain training-specific operations, making predictions more stable. We are disabling gradient computation with this block, saving memory and computations since we are only making predictions, not updating module parameters. We are passing the user and item IDs to the model to get predicted scores for each item. The expand_as method duplicates the user ID tensor to match the size of the item IDs, allowing for batch predictions of all items at once. We are sorting the predictions in descending order and retrieves the indices of the top non-recommendation items, which are the highest scoring items. And we are moving to the top items to the CPU if they are on the GPU, and converting them to a NumPy array for easier handling outside of the PyTorch. This array contains the IDs of the recommended items. With this, our recommender class is complete. This class is designed to generate item recommendations for users based on a trained model. It efficiently handles device selection, CPU or GPU, for faster computation and leverages PyTorch's evaluation and inference tools to produce predictions. The recommend items method ranks item by predicted relevance for a specific user, returning the top recommendations. This structure makes it straightforward to scale recommendations across multiple users and items, optimizing both accuracy and performance.